Here we go, arrays part 2. Hopefully a little bit quicker than the last times. I know when people saw the length of that video, they were thinking exactly what you see on the screen. This will be a little bit better, starting right off the bat with copying arrays. How do you copy an array? Because what if you need to copy maybe the first 50% of an array? If an array of size 100, 50 elements, you need to copy into a new array. Assume you have one array, list 1, and you want to duplicate not just half the elements, but all of those elements into list 2. How would you do that? A beginning programmer will make this assignment. They're going to save list 1 and they're going to assign it into list 2. Now that won't work. Now the reason it won't work is because all we're doing with that assignment is we're saving one address into the location of another address. Remember what's actually inside this array list 1 or this array list 2? It's a reference. It's an address for the beginning of that array in memory. So instead of copying the array, all we're doing is we're copying an address. So if you notice down here, before the assignment, list 1 is pointing to some array. Maybe it's an array of size 10 integers. List 2 is pointing to some other array, maybe an array of 10 doubles. Well, after the assignment, it says take whatever is in list 1, which is an address, to the beginning of list 1 in memory in the heap. It's taking that address and it's saving it into list 2. The consequence of which is both list 1 and list 2 will now point over to the array that is referenced from list 1. So that's actually what happens. And then what happens is because list 2, if you notice here, this actual array, list 2, because no one is pointing to it anymore, it's all by its sad, lonesome self, what happens is the Java garbage collector will immediately come delete it. Java garbage collector has no mercy whatsoever, and as soon as a referenced area of memory, maybe that be an array, an object, or some other data structure, as soon as a referenced area of memory is no longer being referred to or pointed to, Java garbage collector will immediately recycle it for you, which is a good thing, but that also can be a bad thing if you thought you had access to your array, you moved the pointer, you moved the address, and nothing's pointing to your array anymore, the Java garbage collector will immediately delete it. So how do we ultimately copy an array? Because the assignment statement, as we just saw, will copy the address. If we assign one array variable to another array variable, we are simply copying the reference. And now both of those array variables will point to the exact same memory location. It turns out there's 3 ways we can do this. Number 1, once you've made a new array, you can just do a for loop to copy all the contents from the original array to the new array. You could also use the array copy method, which is inside the system class. And there's a third way, which we'll cover later, which is about cloning method, a clone method to then copy our arrays. But let's look at number 1. Here we have this source array, it's of size 5, right? We have these 5 values inside here, and we make a new target array. And we have named these arrays appropriately, source array and target array. What is the size of this target array? Well, we want it to be the same size of the source array. So I could have said equals new int 5, but of course you see it's more appropriate, more general, more vanilla to say equals new int source array dot length. So therefore, regardless of the length of source array, target array will be the exact same length. Now all we do is we loop over source array dot length or target array dot length, right? Same thing. And we're going to save source array at index I into target array at index I. So we're going to save, let's say here we're looping from 0 to less than 5, from 0 to 4. We save source array at index 0 to target array of index 0. Source array of index 1 to target array of index 1. All the way up to source array of index 4 to target array, we save it into target array at index 4. Pretty straightforward. But notice we had to first do what? Create the space for that new array. The second way is by using the array copy method that is found within the system class. So within the system class, we have this array copy method, which has these 5 parameters. And let's take a close look at those parameters. Source array, source position, target array, target position, and then length. Now, source array and target array, those should hopefully be pretty clear. But an important takeaway is that before you can use this array copy method, you had to have already created, declared, and created the space for a new target array. Very important. And so what is source position? It's the index of the starting position from the source array from which you want to begin copying. What is the target position? It's the index in the target array from which you want to begin pasting those values into. And length is the number of elements to be copied. So this is pretty customizable. Here, you can go, if you have an array of size 10 and you want to copy from index 3 through index 5, you could just simply put target source array, index 3, target array, index 3, and what would the length be? We said 3 through index 5, including 5, so 3, 4, and 5. We'd put a length of 3 right there. So array copy is another means of copying the array. And as mentioned, we have to have first allocated the target array. Then we can perform that particular copy using that method. A checkpoint. Once an array is created, its size cannot be changed. Does the following code resize the array? Now you can see the answer, but it's worth talking about. Does this code resize the array? Here we have int bracket myArray. I then said myArray equals new int 10. So now we have an array of size 10 integers, so that's 40 bytes, right? 4 bytes per integer, we got 40 bytes. Well, notice on this line of code, now we say myArray equals new int 20. So if you're thinking, well, did you not just resize the array? No, we absolutely did not resize the array. What actually happened is myArray was pointing over, remember, where the array is created? They're on the heap. MyArray was pointing over, this is the heap, it was pointing over to 40 bytes, an array of size 10, right? 40 bytes, we have this array of size 10 from 0, 1, 2, all the way to index 9, right? 10 cells of 4 bytes each, 40 bytes. But then, after we have this line of code right here, what happens? Look at the assignment. Start at the right side. Remember, our eyes should always start at the right side. This says make a new int array of size 20. So now we're going to have 80 bytes from index 0, 1, all the way up to index 18, 19, right? And what happens is now we're going to assign, pay attention to that assignment, we're going to assign the result of this into myArray. The consequence of which is myArray will no longer point to those 40 bytes in memory. Now myArray is going to point over here to these 80 bytes. So this did not resize the array. What this line of code did is it simply made a new array. And we changed what reference or what address was actually saved into the myArray variable. Super important nuance to understand. All right, how do we pass arrays to a method? Imagine we have this method here, print array. And if you look at what is happening inside the method, we have a for loop. The loop is just going to loop from I equals 0 to I less than array dot length. And we then print array at index I. So I'm looking at this and I see an error at the moment. So why not even fix that error? So let me hit the pause button briefly. And through the magic of a pause button, let's go. You don't have to watch me do that. I changed the name here from array to list because this was previously simply saying array. So we sent over this parameter, right? Here's this method. The method is expecting as a formal parameter. What's it expecting? It is expecting a one-dimensional array of integers. But it's actually more nuanced than that. Because what is saved inside the array variable? Remember that, and we'll talk about it right now. Here we have our main. In our main, we've created this array of size 1, 2, 3, 4, 5, 6 integers, and we saved it into a variable called list. But what's actually saved inside list just an address to this array that was created on the heap. How big is this array? 24 bytes. 4 bytes times 6, right? We have the array on the heap. What is saved inside list? An address. So therefore, pay attention. When I invoke this method, when I call this print method, what am I actually sending over to the print method, to this print array method? I'm sending an address. By typing list right here, which is the correct syntax, I'm sending an address over to that array. So now we come and we look at the formal parameter. We do see it says int bracket list. So we can understand, oh, that's for a 1D array, but know in your heart of heart, what's actually being sent over is an address. An address to what? To the array that's on the heap. What do? We simply loop over the length of the array and we print list at index I, and then we concatenate a space to it. So that's how we send over arrays to our methods. We send the actual address. So here I say we could also have called this method as follows. Notice within the call to the method print array, within those parentheses, instead of sending an address of an array that we already created, look at this. Within the parentheses, we're actually creating an array on the fly, right? In those parentheses, we're saying new int bracket 312642, which is super funky, but it's actually worth looking at and taking a closer look at. So let me code up this print array method, which was not my intention, but why not? Public static void print array int bracket, let's call this just x. What do we want to do? We want to loop over x.length, the length of the array, and at every iteration, we just want to print over, how about print x bracket I. Simple. So here, what we had first shown is we had this list equals, let's say 1, 2, 3, 4, and then we called print array, and we sent over list. We're sending an address. That address got saved into X, and we print it, and it's going to print the values 1, 2, 3, 4. Pretty straightforward. But now, check this out. I could also print array, and here I'm just going to say new int bracket. I'm going to call it the exact same way, new int bracket. And then afterwards, I need to put that shortcut notation. So here, how about I'm going to put 20, 10, 20, 30. So I have sent over to the method an address of this new array that I created. And sure enough, within the method, it's printing 10, 20, 30. Now, if you break down what's actually happening, this is a method call. Within the method call, what do we see here? We see this keyword new. Yo, Java, make me how many bytes? Make me 12 bytes, 4 times 3 on the heap. Take that address and send the address of those 12 bytes. Send that address over here to the formal parameter. That's what's going on. This is not really commonly going to be used, but it's interesting to understand that. The reason why it's not going to be very commonly used is because we now no longer have access in main to this array because we created the array within the actual invocation, the call to the method. So we no longer even have access to it. So it's kind of like, it's maybe silly, and it's not something that you'd really have much use for in most circumstances. It's called an anonymous array. So when passing an array to a method, the address is what is passed. The reference is what is passed. As covered last time, Java uses pass by value whenever we send over our arguments to our methods. The differences between passing primitive data types and passing arrays is for an argument of a primitive, the actual value is sent over as we have seen. But for the argument of an array type, the address is what is sent over. The reference is what is actually sent over to the method. That's the takeaway. And remember, where's the array? The array is saved in the heap. So what's the result of this? This is just repeating what I've already stated, but now it's here on page 78 officially. What's the result of this? When we pass an array to a method, we are sending to that method the address of the beginning of the array within the heap memory. That's what's being sent over. And then inside that method, whenever we access the array via the address that we sent over, we're accessing the memory on the heap. The consequence and the beauty of all of that is that any changes that we make to the array from within this method, any changes we make will persist outside of the method. And here's our first example to demonstrate this. Let's look over here at our method first. So we have a method main, and then we have this method m. This method m, it receives two formal parameters. The first is just an integer that we call number. The second parameter is an int array called numbers. Now, again, I'm going to call it an int array, but we should understand that second parameter is really an address to an int array, which is stored on the heap. So it receives two parameters, an integer, as well as an address to a one-dimensional array of integers. What does it do inside the actual method m? So inside method m, what we're actually doing is we're going to take 1001 and we're going to assign it into the variable number. We're effectively overwriting whatever number we sent over, whatever integer or value we passed over to this method and saved into the formal parameter, we're overwriting it. We're assigning a new value to this variable number. Also, in the second line within method m, what are we doing? We're assigning the number 5555 into index 0 of numbers. So let's see what happens when we run our main. In our main, we have int x equals 1, and then we made a new array of size 10 integers, 40 bytes. I'm saying that just for practice, 40 bytes, 4 times 10. We made a new array of size 10 integers, and we saved the address of that new array into y. So now we invoke method m and we send over x and y. So pay attention, what's being sent over? For x, we're sending over the number 1. So the value 1 is what is saved in x, that comes right here, and that's going to come right over here to number. Now, what is being sent over to method m for this variable y? Well, remember, y is an address. So we're sending over the address of variable y, of that array of size 10 integers, and we're saving that address into this variable numbers. We then perform this method. What does the method do? We said we save 1001 into number, and then we save 5555 into numbers 0. Finally, we then have two print statements. We say x is x, y of 0 is y of 0. Well, this first print statement, x is, what gets printed? Well, it's either one of two options. Either we're going to print the value 1, or we're going to print 1001. Remember, we sent over x as 1. It came here to number. So number was 1. We then overwrote what was inside number, and number became 1001. But x is still 1. We've covered this previously with methods. X is still 1 because x is a local variable, and this variable number is a local variable. We changed the number from being 1, what was sent over as a parameter, to now being 1001. But it's a local variable, so x is still 1. But here's what's important on this example. y0 is, and when we print y at index 0, what gets printed is 5555. Remember, when you create a new array of int values, every single index gets initialized to a default value of 0. So index 0 of the y array had the value 0. But notice over here, when we sent over the address of y, we saved it into numbers, and now we edited what's at index 0 of numbers, and we saved 555 into that index. We're actually editing the value saved on the heap. That's what's going on here. Super important. So this is going to print y0 is 5555. Very important. Here's our stack. Here's our heap. The activation record, we have our method main. We have two variables. We have x is 1, and what is y? Y is an address or a reference that's pointing over to this address on the heap of the beginning of your 40 bytes of 10 integers. We then call method M. Here's the activation record for method M. We sent over x equals 1, which got saved into number, and we sent over the address of y, which got saved into numbers. So what is numbers pointing to? Numbers is pointing to that exact same array on the heap. So therefore, whenever we do this line of code, numbers of index 0 is 5555, we're changing this array on the heap right here, which is changing which is changing the values that both y is pointing to and also that numbers is pointing to. And so you can see that now y, its reference is still pointing to this memory, but index 0 is now 5555. A better example is the following swap example. This is one, again, we showed previously with methods. We have two values in our main, maybe two integer values, a and b. We call a swap method. Inside the swap method, we swap a and b. We then go back to main, and nothing actually swapped in main. But make no doubt about it, in our method called swap, we swapped the values, but they were local variables, so they didn't actually change. So we've seen that example before. We're going to see it again right now, but we're going to edit that example slightly, where we will also send over an array. And inside the array, we're going to swap two values, and we're going to see that those swapped values, that change, it persists outside of the method. So first, I'm going to skip this page. This is the main. I want to show you the two methods. Here we have method swap. It takes over two integers. It receives two parameters, two integers, n1 and n2, and it does the famous 3 lines to swap those two values. We don't need to explain this anymore, right? We have the three famous lines to swap those two values. Make no doubt about it. n1 and n2 have absolutely swapped within this method swap. Those local variables swapped. But in main, before we call this swap method, notice I'll come back to main here. You'll see the values that we sent over, those values will not have swapped in main. Okay, but now look, the difference being we have this swap first to in array method. So we're swapping again, but we're going to swap the first two values in the array. What did we send over? We sent over an address to this method. The formal parameter, it's an address to a one-dimensional array of integers. And what did we do? The same famous 3 lines. We have a temp. We took the value at index 0, saved it to temp. The value at index 1, we saved to index 0. And then the value that we put into temp, we save it back to index 1. So we're swapping what? We're accessing directly the values on the heap. And we swapped those values on the heap, which means those changes are going to persist outside of the method. So here's main. In main, we have a simple integer array of size 2. How many bytes? 8 bytes, 4 times 2. And we have some print statements. Before invoking swap, the array is A0, A1, right? It's just going to be 1, 2 is what's inside the array. Then I call swap, and what do I send to the swap method? Notice this is the swap method, which takes 2 parameters. Each of those parameters should be an individual integer. Well, sure enough, what am I sending? I'm sending the integer at index 0, which is the 1. And the second parameter is I'm sending the integer at index 1, which is the 2. I've sent over those two values. I performed the swap. Make no doubt about it. The swap was performed. N1 has swapped with N2. N1 was 1. N2 was 2. After these 3 lines of code, N1 is 2, and N1 and N2 is 1, if I said that correctly. No doubt about that. But now that we're back in main, after invoking the swap, the array is still 1, 2, because we didn't change the array. We only changed local variables. But check out this one. The takeaway is that here, once again, we print before invoking this other method, we print the array. We're going to get 1, 2. Then we call this method swap first to in array. We send over the address of the array. We swap the actual values in the array on the heap. That's the takeaway. And when we print the result, we see we finally actually made the swap. And that swap, it persisted after the method closed. Now we're back in main, and notice it says after invoking that method, array is, and we get array is 2, 1. The point of this example is that change happened here in this method. The actual swapping happened in the method, but because we're changing the contents of the heap, those changes, they persisted after the method. And here on line 18, when we printed the array, in fact, we see those changes outside of the method, and it will print the array is 2, 1. Very, very important example. Here's just some more detail if you want to pause the video. This is an explanation of what I just gave, as well as this is an additional page of explanation of everything that I just stated. And here is a depiction of what's really going on with that heap memory, with that stack. Now I showed multiple stacks here. Let's see, because I have our main activation record. We then call method swap. We sent over the values 1 and 2. Remember, here's the heap. The heap has the array 1 and 2 on it. Index 0, we have a 1. Index 1, we have a 2. Well, we sent over those values to this swap method. In the swap method, we swapped them, but they were just swapping local variables, not the actual values on the heap. But then, after that method closed, our main method then called this swap first to in array method, a new method on the stack, which accessed the exact same heap contents, and we actually swapped the values on the heap. We have one example, to just really an animated one to run through very quickly. We want to show how you can return an array from a method. We showed how to call a method and send over an address. What about returning from a method? How do you return an array from a method? You really just return the address. It's super simple. That's not really what this example about. This is just an example on how to reverse an array. It's pretty straightforward, but we'll go through it. But we want to talk about how to return an array from a method, and the answer is you return that address. You return the reference. So here's some code. Let's look at it. We have this reverse method. We're sending over an address to an array that we've called a list. It's an array of integers. And we want to do what inside this reverse method? We want to create a brand new array of the exact same length. That's why it says new int list.length. And we're calling that array result. And it's an array of integers. And what we want to do is we basically want to take the goal of this method is if we had this, let me erase all of this stuff. The goal of this method is if we have an array with contents of 1, 2, 3, 4, 5, we want to make a new array with contents 5, 4, 3, 2, 1. We want to make a brand new array with those contents. So that's why, given this array called lists, we've made a new array called a result of the exact same length. And now let's see what we're going to do. We're going to loop starting from, and notice this is kind of funky here. We have 2 initial actions. Notice it's I equals 0, comma, j equals result.length. That's kind of funky. That's new for us. We have 1 loop continuation condition. We're going to keep looping as long as I is less than list.length. And then we have I++ and j-, which we have 2 actions after the loop. We've said that that's allowed, but this might be the first example we've shown where we're actually doing that. And here's what we do inside the loop at every step. I'm going to come to the animation, and it'll be clearer as we go through this. So just want to show that inside our main, this is what we have. We've made this array of size 6 with these values. And then we've made this call in our main. We've said int bracket list2 equals reverse list1. So we're calling this reverse method. and we're sending over the address of list 1, of this array that's on the heap. We're sending over the address. Let's not worry about what gets assigned into list 2, but let's pay attention to the call. We're calling the reverse method, and we're sending over the address of list 1. And here's list 1 right here, and here's the call. So what actually happens? Well, the first thing, as I mentioned, we're going to declare this array called a result of the exact same size, and of course it defaults to 0. Done. Now we have these initial actions. I is 0 and j starts at result.length minus 1. So I is 0 and j is going to start at index 5. Now we have I, make sure it's less than list.length. Is I less than 6? It is. What do? Take index for the list of I, and I is 0, take I equals 0 and save it over here to result at index 5. This is the consequence. The 1 got saved over because we're reversing it. The 1 at index 0 of list got saved over to the index 5 of result. What happens now? I plus plus and j minus minus. So now I is 1 and j is 4. I is less than the length. What do we do here? We take list at index 1, save it to result at index 4. And you can see what's going to happen now. The next one, we're going to take list at index 2, save it to j at index 3. Well, how do we get I is 2 and j is 3? Well, that's right here. That's the next step. I plus plus, j minus minus, I becomes 2, j becomes 3. 2 is less than 6. Do it again, and we keep just looping over, and we are reversing. Here we saved list at index 4 into result of index 1. I plus plus, j minus minus, I is 5, j is 0. I is 5 is still less than 6. So we're going to save list at index 5 to result at index 0. That's now finally is fully reversed. Here, when I do the I plus plus and j minus minus, I becomes 6. 6 is no longer less than the length. We're going to break out of the loop, and what happens? What happens is we return result. Well, what is result? What is result? Result is an address. Result is a reference, right? We've made, this is an assignment, make a new array on the heap, but what's saved into result? An address. So when I type return result, and even look at the data type being returned, it says int bracket. What that means is return an address that's referring to an array of a one-dimensional array of integers. So when we return result, we're actually returning an address. And so I want to go back to that first line, or right here is good. I'll come back to the previous page. So when I call this method and I send over the address, what got returned? An address of the new method, of the new array. And what did we save into list 2? We saved that address into list 2. All right, we had a checkpoint. When an array is passed to a method, a new array is created inside the method, true or false. Pause the video, think about it if you need to. Hopefully you know that one clearly. Absolutely the answer is false. There's only one array. That array is on the heap. When we pass an array to a method, we are merely sending the address to that method. So here's what we're going to end with. I'm being cognizant of time. We're at 33 minutes. We did all of these examples on the array part 1 video. See, this is the last page. We're done after this. Let's go. We're close, right? I want to now redo those examples in the next 10 minutes, but this time using methods. And I encourage you to pause the video and code this up with me. And this is going to be more fun. It was painful to do all of those examples without methods last time. Let's now code them up with methods. So I want to remind you of where we were. So last time, we made all these examples: print an array, generate random values, print those values, sum them up, find the maximum, right? Then we did the shuffling and other things. It was just nasty without using methods. And the reason I did that is because we didn't know methods as of that point. Or not methods, we didn't know how to send arrays to methods. So let's redo this exact program of processing all these different portions of an array. but now using methods. So starting with printing arrays. Cool. I'm going to do this up here. So public static void print array int bracket arr and a for loop. How do we want to print our array? It's going to be arr.length. And we could just do this. We could do like 1 per line arri and just do that. And let's see what I mean by this. So I'll keep the random here because I'm going to need, I'll erase it and we'll type it again. Okay. So for example, let's just say that I want to make a new, so make a new array of size 5. So here, int bracket arr1 equals, let's do it this way. 1, let's do 10, 20, 30, 40, and 50. And so now I want to call this print array method. And I want to send over arr1. I want to print it. When we print it, we just get this. It doesn't look very good, right? We're just printing 1 per line. So how can we make that look better? How about if we printed, let's do formatted printing. So let's make this printf. Put a comma here. And inside here, what if we printed arr bracket %d bracket equals, or colon %d, new line. What do we want to print here? Array at index something equals something. Well, here, this %d is I want to print the index, right? And then this %d is I want to print the value at that index. That's my intention. So I want to do this. So now when I run this, check that out. Array 0, 10, array 1, 20, all the way to array 450. That looks pretty good. I'm going to make another modification to this, but not just yet, because I don't want it to be confusing why I'm making that modification. That modification will come shortly. But now we have a generic print array method. We're going to make it even better and more generic. And you know what? Even after the for loop is done, let's make just a print statement. So for some spacing, here we go. Cool. Initialize array with input values. I'm not going to do that one because, I'll code it briefly. As a method, not really. But initializing an array with input values is, I'll code it once, but I don't want to talk too much about it. I don't want to be running it because I have to put input values every single time, which would be a pain. So here, what if I had int bracket arr2 equals new int bracket, let's say of just size 4. And, nope, what am I saying? I want to make a method called initialize array with input values from user. Let's make it like very long. And I'm going to send over arr2. So now I need to make this method. Public static void. There's the name of the method. And what did I send over? I sent over arr2. What is arr2? It's an address. An address to what? An array of integers. So here, int bracket. It's an array of integers. And I'll call it again just arr. Again, I can call it here anything I want. I'll call it just x, right? Inside here, what am I going to do? I need to make a scanner, which is kind of dumb. I would normally not make a scanner in a method, but I don't have a scanner in main, so I can make it in a method, no problem. Scanner in equals new scanner system.in, and now I need to loop over x.length, which is the array. I need to loop over x.length. And what am I going to do in here? I'm going to x at index I equals n.next int. That's it. I have now initialized this array with input values. But the takeaway is, notice where am I doing this? I'm doing it inside the method, and that will persist outside the method, because now if I type print array, array2, right, arr2, watch what happens. It did this. It's waiting for input values. I guess I should have prompted. Let me do this. Let me prompt in here. Enter an integer. And let's make this a print statement. Run this code. Enter an integer. Let's enter 8, 9, 10, 11. And so here's the result. Array 0 is 8. array at index 1 is 9, 10, and 11. So pretty straightforward how that's working. But I want you to see the takeaway is we made the array within main. Where was that array actually saved on the heap? How many bytes? 16 bytes. So where did we read those input values from the user? We read that actually inside this method. So in this method is where we saved stuff into the array, right? We saved the stuff into the array from in this method, but all of that data, it's okay. It persists outside of the method. Even when the method closes and finishes and returns, it's a void method, right? So after it finishes this line, this loop, and it returns back to main, those values are still saved inside the array. Why? Because they're saved on the heap. Cool. So now that we've done that, I'm just going to erase this because I don't want to be doing input every time I run this. All right, what next? Initialize an array with random values. Cool. So int bracket ARR2 equals new int. Let's make it of size 10. And let's call this init array ARR2. And let's do this one. Public static void init array int bracket, and I'm going to call this ARR again. Pretty creative. That was sarcastic. ARR.length. Oh no. Okay, ARR.length. And I want to initialize it with random values. Each index from, how about 1 to 100 inclusive. So that means we need a random, right? We need a random generator. So random RNG equals new random. Cool. And what do we do inside here? We're going to say ARR at index I equals RNG.nextInt from 1 to 101. Remember, it's not inclusive. If I want from 1 to 100, I need to put 1 to 101. So I have now looped over the length of the array, and at every single index, from index 0 all the way to index 9, because remember, it's length 10, I'm making a new random number, and I'm saving it into that index. And now, let's print the array. Print array ARR2. And let's see what we get. Check it out. Here's that first array of size 5. Let me come up some. Cool. Here's that, let me run it again. Here's that first array of size 5. And then here's that next array that we just created. Of course, it's random. I can generate a different set of random numbers each time I run this. Done. So what I'd like to do as well, notice here, they're both saying ARR is the name of the array, but that's not really true, right? What's the name of this array? That's ARR1, right? This is ARR2, but they're both saying ARR. Why are they both saying ARR? The reason why is because our print method, I literally said print ARR, right? So here's where I said I'm going to edit the print method. This is kind of overkill, but why not? Let's send over a second parameter called name. String name. You can call it name of array if you wanted. So here, instead of printing ARR, I want to put %s. So the first thing I'm going to print, the first placeholder of formatted printing that I need to print is this %s, which I want to be the name of the array. So I'm printing three things: the name of the array, followed by the index, followed by the value of that index, which is this. So now when I call those print methods, I'm going to send over ARR1, and I'm going to send over the name of the array as a string. Maybe overkill, but why not? So now it's going to make it a little bit better. And when I run the code, hit run, I get here ARR1, and here's ARR2, because I'm sending over the name. So better yet, let's call this random array, and there you go. So random array, index 0 is a 1, index 1 is a 1, jeez. All the way to index 9 is a 40. And here we go is another set of random numbers. Cool. What next? Sum all elements. That's an easy one. Check this out. sum all elements in random array. So we need to write a method. That method should write a method to sum all elements in a given array and return that sum. Public static int sum values, and we need to send over int bracket ARR. What are we going to do? Int sum equals 0. We've done this before. Do a for loop, loop to ARR.length, and we're going to sum plus equals ARR at index I. See how easy this is? And then return sum. If you've been kicking the ball, that's it. So now I can say, I can make a print statement, print f, and I can say the sum of all values in the random array is %d period new line, comma, and here's where I'm going to call that method. Because remember, I'm going to call the method. Now I could have done this. I could have said int sum equals sum values, and I want to send over here random array. I could have done that, and then here I just print sum. That'll work just fine, right? The sum of all values in the array is 594. That would work, but I'm just going to do it right in the call. I'm going to do it right here within the formatted print statement. The sum of all values in the random array is this. Now, I do notice as I'm running this, because every time you run it, we get different generated numbers. It's based off of the seed. And so we should change that seed so you can be consistent and have the same value. So I'm going to go to this the init array method, where we have to make a new random object. And then I'm going to make a new comment. Set the seed of this random object to, let's pick a number. How about we call the number 357. So RNG dot set seed, and I'm going to put in here the number 357. Some of you have maybe seen this before, others may not have. This is I call this a random number generator. And I explained random number generators as follows. Think about that you're growing random numbers from this tree. The random number generator is this tree, and it's growing out these random numbers. It's an algorithm. That's why they're called pseudo-random numbers. They're not truly random because it's just an algorithm that spits out these random numbers. So we're growing this tree. Why am I saying growing the tree? You'll see why. We're growing this tree of random numbers. And if we start the very seed, like a tree grows from a seed, right? A fruit plant grows from a seed. Well, if we start our random number generator tree from the exact same seed, we will get the exact same random numbers. So notice I ran the program. Here's the result of my array. When I run it again, I get the exact same random numbers every time I run it. The value of which is, if we use the same seed, 357, we're going to get the exact same numbers, and you can make sure that your data is correct. So here I have the sum of all values in the array is 588 based off of that seed. I will use 357 as the seed, but just to show you, if I make the seed a different number, I make the seed 1,000, for example, I'm going to get a different set of random numbers. So I'll go back to 357 and I'll keep that one. So this is our seed, 357, and we result in these random numbers, and here is the sum of those values. Hopefully that one's all right. Finding the largest element. Check this out. Let's go. This shouldn't be that bad. Find the largest element in the random array. I'm going to do a formatted printing statement. The largest element, type faster and better. Largest element in the random array is %d period new line. Largest element in array. It's a long method name, but it's clear, right? Random array. Done. Now it's not working because I didn't make the method yet. No problem. Let's come make that method. I'm going to copy the name. Let's make it. Public static int paste int bracket ARR. I want to find the largest value. And I'm going fast over these because we've already explained it on part 1. These are the exact same problems already explained. I'm just redoing them. So largest element in array, here we have int max. Remember, we should initialize max to integer dot min value. And we're merely going to loop over. And I'm loop to arr.length. And I'm going to check if what? If arr at index I, if it is greater than our max, guess what? Max equals arr at index I. That's it. And then afterwards, I need to return my max. Right? This is the value. I'm saving it to here. So if it's greater than our max we initialized to the smallest possible value of integers. And so, of course, whatever's at index 0 will be greater than our max. And we're going to keep checking every single index. If it's greater than our previous max, well, then we have a new max. Run. The largest element in the array is 100. Sure enough, it was 100 at index 0. And that's what was found. If you want to change the seed, briefly, let's change it to 555. Just to see that that's working. The largest number is 97, which is true at index 5. We have a 97, right? What else was left? Find the smallest index of the largest. I don't want to do that one. Random shuffling. I'll do one more. What was random shuffling? So let's do this. Public static void shuffle. ARR. Nope. Int bracket ARR. And we want to do a shuffle, which means we need to make another random here. We need to randomly generate 2 indices, in which case, let me go all the way back to my main. Where's my main? My main's there, but I want to get my seed. I want to take my random. I'm going to make that in my main. So I'm going to send over random RNG as a parameter to that init array method because I want to make my random in my main so I can send it over to these methods. So here I'm going to send over RNG and also on the shuffle. So I'm going to call shuffle and I'm a random array. And I'm going to send over RNG as well because I will need, so shuffle the random array. And I will need a random number generator in order to generate those indices to shuffle them. So here, got 2.5 minutes. I want to finish at 55 minutes. I need to do what? Shuffle. I need to have comma random RNG. I need to have 2 indices, int idx1, idx2. I also need a temp. And let's do a for loop. We're going to loop how many times? We can loop as many times as we want. How about we loop array.length times? And what are we going to do at every single iteration? We're going to generate 2 indices. Index1, idx1 equals RNG dot next int. We want to go from 0 up to the length of the array. And we want to do this for index 2. That's done. We then want to swap the 2 indices, swap the values at those randomly generated indices. This is going to be using the famous 3 lines. So we have our temp equals ARR at index IDX1. Then we have ARR at index IDX1 equals ARR at IDX2. Again, we explained this last time. And then ARR at IDX2 equals temp. Those are the 3 lines. We now run that code, but before running it, let's print it afterwards. Print array, and this is going to be the random array, and then the string version. Come on, double click, paste, paste, and here's the name. That was fast, but let's see. Here's the array. We went from index 0 of 39 to 93. I was about to say it didn't work, but it did work. 39 to 57. And that I only shuffled it, I shuffled it the length of the array times, which was 10 times. I could have just said, you know what, let's just shuffle it. What is this? That is 1,000,000 times. Let's do 1,000,000 shuffles, if you will. and we get this result as well. So that's a lot, but this is just practicing with arrays, practicing sending over the methods to the arrays. We are done sending over addresses, manipulating those arrays on the heap, returning the addresses. It actually is a lot of fun, but we need practice, need to kick the ball. As always, reach out if you have any questions. It's been fun. Take care.